So, welcome to lecture number 34 of fuzzy sets, logic and systems and applications. This lecture is in continuation to our previous lecture, where we discuss the properties that was relation with the fuzzy relation and the crisp relation. So, in the previous lecture we discussed some of the properties listed here. So, we discussed the law of contradiction, law of excluded middle, idempotency, involution and commutativity with respect to fuzzy relations. And we saw that we had law of contradictions with respect to the fuzzy relations, law of excluded middle with reference to fuzzy relations. So, these were not behaving same as the crisp relations, these two properties, and now the idempotency, involution, commutativity, all these three properties were satisfied, were holding good when we took fuzzy relations. So, let us now move in continuation to these properties. Let us come to associativity, and when we take crisp relations R, S, T. So, these crisp relations show the associativity for union. So, as it is mentioned here that if we take the union of R and S and then take the union with T of it, we get this same as the union of R and the union of S and T. So, this is true for this is holding good for the crisp relations. Now, when it comes to fuzzy relations R, S and T, here also the associativity for union holds good. So, let us verify this by taking one example, and in this example here we have taken three fuzzy relation sets. So, we have taken R fuzzy relation set, S fuzzy relation set and T fuzzy relation set. Now, when we take the union of R and S, we are getting here this fuzzy relation set, and as we already know that we take the maximum of the respective membership values, and with this we get the R union S, and the process is shown here, you can follow. And then here we take the union of R union S and T. So, here when we take the whatever we have got here as R union S, now we further take the union with T here, we get here this fuzzy set as result. So, this is nothing but the R union S and then the union of it with T. So, this is what we are getting. Now, let us take the S in union T. So, S union T is here, S union T, and then take the union of it with R, and we take R first as it is here. So, if we take this, we are getting here this fuzzy relation set, and in the matrix representation we see that we get R union of R and S union T. So, if we compare this with the previous outcome, which was nothing but the union of R and S and then the union of it with T. So, we see that these both the sets are same. So, we can say that the union of R union S and T is equal to the union of R and union of S and T, and these R, S and T all are the fuzzy relation sets. So, this way we see that the associativity property for union holds good for fuzzy relation sets R, S and T. Now, let us check the associativity for intersection, and we already know that if we take crisp relations R, S and T, this relation, this property, that means the associativity for intersection is satisfied. So, we are not going into it. Now, let us understand this relation, that when we take fuzzy relations R, S and T, the associativity for intersection is also holding good. So, let us verify this by taking an example for this property. So, here also we take R, S and T, as you can see here, these three fuzzy relation sets we have taken, and let us first find the intersection of R and S. So, when we use the min criteria here, we find here this outcome as the R intersection S, and then whatever we get here is again intersected with the fuzzy relation set T as it is shown here. So, when we try to find this, again the intersection of R, intersection S and T. So, we find here this outcome. So, this is nothing but the intersection of R, intersection S and T. Now, let us find the intersection of S and T. So, intersection of S and T is here, and when we take the intersection of this fuzzy set, which we have found here as S intersection T, the intersection of S and T and the intersection of R and the intersection of S and T here. So, if we find that, we find this outcome. So, now when we compare this, we see that these both the outcomes are same. So, this means that the intersection of R, intersection S and T is equal to the intersection of R and the intersection of S and T, which is here. So, this way we can say that associativity for intersection is satisfied for fuzzy relation sets. Now, let us move to the distributivity of union over intersection. So, when we take crisp relations R, S and T, we know that this is satisfied. So, we are not going into it, we are not going to discuss anything about it further. However, if we take fuzzy relations R, S and T, we see that the union of R and intersection of S and T is equal to the intersection of R union S and R union T. So, let us now verify this. So, this holds good for fuzzy relations R, S and T. So, this is called distributivity of union over intersection property, and this holds good for fuzzy relation sets. Let us take an example and verify this quickly. So, here we have taken 3 sets, 3 fuzzy relation sets, and let us take the intersection of S and T. So, intersection of S and T, which is here, which we get like this, which this is the outcome of the S intersection T, and let us take the union of this S intersection T with R. So, when we take this, we are getting this as the R union S intersection T. So, let us move further and see whether the distributivity of union over intersection is verified here. So, in order to do that, let us first find the union of R and S. So, union of R and S outcome is here. Then we go to find the union of R and T. So, union of R and T is here, union of R and T, and now we take the intersection of these two fuzzy relations. So, let us take the intersection of these two. So, when we take the intersection of these two here, we get as a result here a new fuzzy relation set, which is represented by fuzzy relation matrix. So, we see that this outcome is same as this outcome, means the union of R and the intersection of S and T is equal to the intersection of R union S and R union T, which is here. So, this way we can say that the distributivity of union over intersection is verified for fuzzy relations R, S and T. So, let us now go to the next property, which is distributivity of intersection over union, and we all know that is holding good for crisp relations R, S and T, and also we know that this property, the distributivity of intersection over union is satisfied, is holding good for the fuzzy relations R, S and T also. Now, let us verify this relation by taking an example like previously we have done for other properties. So, let us once again take the fuzzy relation sets R, S and T, and then since we have to verify this property, that means the distributivity of intersection over union, that means the intersection of R and union of R and S, and which is equal to the union of R intersection S and R intersection T. So, let us first find the union of S and T. So, union of S and T is here. By applying the Max criteria, we get the S union T. Similarly, when we take the fuzzy relation set R and we take the intersection of R and S union T, we get this outcome by applying the min criteria. So, we can write this as intersection of R and S union T. So, the outcome is here, and now let us go to R intersection S. So, R intersection S is here. When we take R and S, take the intersection. So, this is R intersection S, and here we have the R intersection T. Now, if we take the union of these two, so when we take union of these two, means the union of R intersection S and R intersection T. So, when we take this, since we are taking union, we take the max, we use the Max criteria, and when we use this Max criteria, we are getting here this as the outcome. So, we get a new fuzzy relation set, and which is nothing but equal to, you see here, equal to this fuzzy relation set. So, this way we can say that the outcome of the intersection of R and union of S and T is equal to the union of R intersection S and the R intersection T. So, this way we can say that the distributivity of intersection over union is verified for fuzzy relations R, S and T. Let us move to the next property, which is absorption of union over intersection. So, here for crisp relations R and S, it is like this, like we take the union of R and R intersection S, we get here R. So, this is holding good for crisp relations, and when it comes to fuzzy relations R and S, here also the absorption of union over intersection holds good, means the union of R and the intersection of R and S is equal to R. So, let us this also verify by taking an example. So, here we have taken one fuzzy relation set R and another fuzzy relation set S also we have taken. So, R and S both are the fuzzy relation sets, and now let us verify the absorption of union over intersection. So, for this let us find the intersection of R and S. So, since here we are finding the intersection, we use min criteria, you see here, and when we use min criteria, the outcome is this. So, this is nothing but the intersection of R and S. Now, this outcome is again used for union with R. So, when we take the union of R and R intersection S, now since we are taking union, we use the max criteria here, and then the outcome here is like this. So, the outcome here is like this, and which is nothing but the fuzzy set R which we have taken. So, we can say that the union of R and the intersection of R and S is nothing but R. So, this means that the absorption of union over intersection is verified for fuzzy relations R and S. Now, let us move to another property, which is absorption of intersection over union. So, here we have the R intersection R union S, means the intersection of R with R union S, and this is equal to R. So, this holds good for the crisp relation sets, and the same also holds for the fuzzy relations R and S. That means, if we have two fuzzy relation sets R and S, so the intersection between the R fuzzy relation set and the union of fuzzy relation set R and fuzzy relation set S, we are going to get R. So, this means that absorption of intersection over union holds good for crisp relations as well as fuzzy relations. So, let us verify this by taking an example. So, here we have taken two fuzzy relation sets R and S, which we can see here, and then now let us try to verify for absorption of intersection over union. So, when we do that, in order to do that, we first find the R union S. So, R union S is here. So, we use max criteria for union. So, we get the R union S here, and then we take intersection of this with R. So, we take R first and then we take the intersection of R with R union S. So, since we are taking the intersection here, we use min criteria, and then when we use min criteria, we are getting this as the outcome, and this outcome if we compare, this is nothing but the R. So, we can clearly say here that the intersection of R and the union of R and S is going to be equal to the same set R. So, here this absorption of intersection over union is satisfied, the R we can say it is verified. Now, let us go to the absorption of complement for union. So, here we have the relation sets, crisp relation sets R and S, and we see that when we take the union of R and the intersection of R bar and S. So, this comes out to be the union of R and S. So, this holds good for the crisp relations, but when it comes to fuzzy relations, this does not hold good. That means, when we have fuzzy relations R and S, if we take the union of R and the intersection of R complement and S is not going to be equal to the union of R and S. So, this way we can say that the absorption of complement property for union does not hold good for fuzzy relations R and S. So, let us quickly verify this by taking an example. So, we have taken here in this example fuzzy relation set R and fuzzy relation set S. So, let us first find the complement of R. So, the complement of R is here, I am writing just complement of R, and then let us take the intersection of complement R and S. So, this is the outcome. Since we are taking the intersection, we use the min criteria, which is clearly visible here, and then when we have taken this, then let us take the union of R and this outcome. This outcome means the R complement intersection S. So, when we do that, we are getting here as the union of R and complement of R intersection S. Now, let us find the R union S. So, we have R, we have S. Now, since we are taking union, we use max criteria, and when we find this, we see that we are getting here as the R union S. When we compare this outcome with the union of R and the intersection of R bar and S, we see that both of these are not same. So, when both of these are not same, we can say that the absorption of complement for union is not holding good. Now, let us check the absorption of complement for intersection. So, on the same lines we see that the crisp relations R and S, these relations are holding good. The absorption of complement for intersection means when we take the intersection of R and the union of R bar and S, this is equal to intersection of R and S, and if we take the fuzzy relations R and S, so this relation does not hold good, means this property does not hold good when we take fuzzy relation sets R and S. So, that means if we have fuzzy relation sets R and S, and if we take the intersection of R with the union of R complement and S, this is not going to be equal to the intersection of R and S. So, let us verify this also, and for this if we take our fuzzy relation set here as R, one of the fuzzy relation sets, as R and then another fuzzy relation set S here. So, when we take these two fuzzy relation sets, first fuzzy relation set is R and the second fuzzy relation set is S. Now, let us first find the complement of R here, which is coming out to be like this. So, this is R bar, and then when we take the union of it with S. So, since we are taking union, so we use max criteria as we can clearly see, and then the outcome of union of R bar and S is here. So, this we write as the R bar union S, and then we take the intersection of it with R. So, that means the intersection of R and R bar union S. So, this is the outcome of it, and now let us further find the R intersection S. So, R intersection is coming out to be this. Now, we see that the intersection of R and union of complement of R and S, which is here, and this is not equal to the intersection of R and S. This clearly shows that the absorption of complement for intersection does not hold good when it comes to the fuzzy relations R and S. So, now let us go to the another property, which is De Morgan's law of union. So, we already know that when we take the complement of R union S, we get the R complement and the intersection of it with S complement. So, when we take fuzzy relation sets R and S, this property also holds good for the fuzzy relation sets. That means, either we take fuzzy relations or we take crisp relations. For both the relations, De Morgan's law of union is holding good. So, let us here also we take one example and we see as to how De Morgan's law of union is verified for fuzzy relations R and S. So, when we take the union of R and S for this fuzzy relation set R and S. So, R and S we are getting like this, we use the union. So, that is why we take the we use max criteria, and when we use max criteria we get R union S, and then when we take the complement of it we are getting this outcome. So, this is nothing but the complement of R union S. Now, we take the complement of R, which is this, and then we take the complement of S, which is this. Now, when we take the intersection of R complement and S complement, so we see that this is equal to the complement of R union S. So, this way we can say that when we take two fuzzy relation sets R and S, we take the complement of R union S, and this is nothing but is equal to the intersection of R complement and S complements, which is here. So, De Morgan's law of union for fuzzy relation sets is holding good. Now, let us verify the De Morgan's law of intersection. So, here also we see that if we take the complement of R intersection S, and then it is going to be equal to the union of R complement and S complement, and this is holding good for the crisp relation sets as well as the fuzzy relation sets R and S. So, let us verify this also. So, when we take two fuzzy relation sets here as R and S, and let us find the intersection of R and S first. So, this is the intersection of R and S, and when we take the complement of it here. So, this is the outcome when we take the complement of R intersection S, and the complement of R is here, complement of S is here. So, we see that when we take the union of R complement and S complement, we get this as the outcome. So, we get the new fuzzy relation set as the outcome in form of the matrix here. So, this is nothing but this is equal to the complement of R intersection S. So, this way we can say that the De Morgan's law of union for fuzzy relation sets is holding good. So, in today's lecture we have studied the following properties of fuzzy relations: associativity property, distributivity property, absorption property, absorption of complement property, and De Morgan's law. And this we have seen as to how the fuzzy relation set holds good with respect to the properties that I have already discussed in this lecture. And in the next lecture we will study the fuzzy extension principle. Thank you.